So we are in module 1, quiz 5, and the first problem is giving us probability of A, condition on B, and what the problem is asking, what is probability of B, condition on A. And remember, this quiz was all about base theorem. So how do you answer this question? How do you go from probability of A condition on B to find the probability of B condition on A? So we write this conditional probability, that's probability of A condition on B, divided on probability of B, and I can rewrite the numerator as probability of B condition on A multiplied by probability of A divided by probability of B. And now I have pretty much everything from problem statement. Probability of A condition on B is 0.7. Probability of B condition on A is what I want. Probability of A is 0.5 and probability of B is 0.2. So with that, you can easily find probability of B condition on A is 0.2 multiplied by 0.7 divided by 0.5. Okay, so this one was relatively easy. It was just conditional probability formulation. How about the second one? Is there any question regarding the first one, guys?
No.
Okay. Let's go to the second one. So, second problem. A recreational equipment supplier finds that amongst the orders that include tents, 40% of them have sleeping mats, 5%. So among the ones that have tents, only 40% have sleeping mats. And among the ones that do not have tents, 5% have sleeping mats. And overall, 20% of orders include tents. Okay. What is the probability that the order includes a tent, given that the order includes a sleeping mat? So let's see the steps for solving the problems generally in probability. First, write down what question wants from you based on the probability notations. So the question is asking, what is the probability that the order includes a tent, given that it includes a sleeping mat? How do you write this question based on probability notations? Tell me the answer. What is the probability that the order includes a tent, given that it includes sleeping mats?
It would be PT given S.
Probability that the order has tents, given that it has a sleeping mats. So I'm going to write it as probability of T, given that S. Okay, so that's good. Now, write this based on the formula. So how do you write this conditional probability? The formula
PT, probability of the tent, intersection sleeping mats over probability of the sleeping mats.
Okay, that's the second step. First, write the probability that the formula has, write the questions that the formula wants from you in terms of probability notes, and then write the formula if there is any for that question. Third, find out what is given to you in the problem statement. So now let's go through the problem statement one more time and just write down what is given to us. A recreational equipment supplier finds that among orders that include tents, 40% of them have sleeping mats. How do you write that?
Probability of sleeping mat given tents is 40%.
Okay, so among the orders that have tents, 40% of them have sleeping mats. So the parts that we are sure about is that the orders have tents. We know among the orders that have tents, for sure, 40% of them have a sleeping mat. So that's probability of having tent for sure. Then what is the chance that they also have a sleeping mat? That's 40%. So, and then it says only 5% of the orders that do not include tents have sleeping mats. How do you write that part?
Probability of sleeping mat given and not tents. So T complement
So the
is
probability,
0.05.
okay, great. So 5% of orders do not include tens. Sorry, for 5% of the orders that do not have 10, we know that for sure. The orders do not have 10. Out of those, 5% include the sleeping mat. So we know for sure they do not have 10s. So how many of them, what percentage of them have a sleeping mat? 5%. We also know that 20% of orders include tens. What is that?
Probability of tens.
Is 20%. And as a result, probability of no tens is 0.8.
0.8.
Okay, so these are all that has been given to us in the problem statement. Now, and remember what we want to calculate is this value. So now let's look at the numerator. Probability of that an order has tent and sleeping mat. Do I have this probability in the problem statement? These are the 4 elements that have been given to me in the problem statement. Do I have probability of tent and sleeping mat?
No.
No. Denominator. I need probability that an order has a sleeping mat. Do I have that?
No.
So I don't have numerator, I don't have denominator. Okay. Now let's see how we can do this calculation. So remember what I need to calculate is probability of T and S divided by probability of S. I do not have the numerator and denominator in the problem statement. What should I do? I have to rewrite numerator and denominator based on the probabilities that I have in the problem statement. How can I rewrite the numerator?
Probability of sleeping mats intersection tens. Because it's the same thing.
Multiply by probability of tens. Okay,
Yeah.
and let me just explain something here before we proceed further. Okay, guys, for the numerator, I'm just talking about numerator. How many ways I can write the numerator? Can you tell me?
You could write it as P of S intersection T intersection T.
Okay, multiply by probability of T. What is the other way? Probability of? Do you guys hear me?
T given S times S.
Multiply by probability of S. We talked about this in previous session, guys. Okay, so this should be like the first thing on top of your head. So I can write this probability of T and S based on either the first formula or the second formula. Both of them are the same. Which one I'm going to choose here?
S given T, because we have that.
I'm going to choose the first formula because the components of the first formula, these two, are the ones that have been given to me in the problem statement. The first one is given, the second one is given to me as well. So I'm going to pick the first method for rewriting probability of T and S. Okay, so that's my numerator. How can I rewrite the denominator? Probability of S. Remember, guys, I told you
as the summation of all the parts of S. So S given T times T and S given T naught
or
times T naught. Yeah,
Okay.
and that's it.
So now, how can I write? So what is the numerator? Probability of S condition on T?
40.
0.40%. What is the probability of order having 10th?
2. 20.
Okay. And the denominator, this part is similar to the numerator. And what is probability that the order
0.05 times
sleeping math
0.8.
given that no 10th, sleeping math given no 10th is 0.05, and probability of no 10th is 0.8. And that's the answer to this probability. Okay. All good? And as you
E.
can see, the problem is 0.66. The answer. Okay. If there's no question, I'm going to go to the next one. An email filter is planned to separate valid emails from spam. The word free contains 60% of the spam messages and only 4% of valid messages. 20% of the messages are spam. What is the probability that the message is a spam given that it contains the word free? So first, write down what question wants from you based on conditional probabilities. So what is the probability that, not conditional probability, based on the probability notations. What is the probability that the message is a spam given that it contains word free? How do you write that?
Probability of spam given free. P given PS given F.
Probability that the message is a spam given that we see the word free. Give me 1 second. Philip, is that you who is answering?
Yeah.
Can you please not answer so other students?
Okay.
I appreciate that. Thank you. And I appreciate the fact that you know everything. That makes me happy. Okay. So that's what question wants from you. What is the probability that the message is a spam given that the word free is in there? How do you rewrite this? What is the not rewrite, what is the formula for conditional probability?
It's gonna be probability of free given spam times.
No. Just write this. Just write the conditional thing.
Yeah. Free given spam times.
No. I don't say this or just write the formula of conditional probability. Spam and free.
Oh, that's what I'm doing. Okay. I see. Never mind. Given free.
Just a simple definition of probability. Yeah, you are giving me the ultimate answer, but I wanted to get there.
The base term, yeah. Okay.
Yeah. Okay. So I just want to show how we get there. So that's why I wanted to. Okay. So this is the definition. So now let's read this is just the definition of conditional probability. Now let's read the problem statement and see what is given to us in the problem statement. The word free occurs in 60% of spam messages. How do you write that? These are all you guys you have to be able to do. So you have to be able to read the problem statement and extract what is given to you. So what you are trying to answer right now is basically the skills that you have to develop in this class. There is no formula behind how to extract the information from the problem statement. You just have to do it over and over and over to get good at it. It's not hard. It just needs practice. And these examples we solve in class are just extra practice. So answer the questions. Participate is for your good. What does this word mean? The word free occurs in 60% of the spam messages. How do you write that?
Probability of free given spam.
So the word free occurs in 60% of the spam messages. So the part that we're sure we know is that the message is a spam. We are sure about that. And then 60% of those have the word free as well. Okay. How about the next one? It says only 4% of the valid messages contains the word free. So the word free occurs in 60% of the spam and only 4% of valid messages. What does that mean?
P free, not spam, or given, not spam.
Okay, perfect. Is 4%. Okay. Now, what else? Also, 20% of messages are spam. How do you write that?
P spam.
Is 40%. Okay, so this is all that has been given to us in the problem statement. So now, remember what I want is this. Do I have the numerator in the problem statement? Is it given to me? Probability of
No.
email have spam and having the word free. Do I have the probability of denominator?
No.
No. Then I have to find ways to rewrite the numerator and denominator. How can I rewrite the numerator? It's probability of. Remember, I only have these three things in the problem statement. I have to somehow rewrite the numerator based on these three things. How can you do that?
Probability of free given spam.
Perfect.
Probability of spam.
Perfect. How about denominator?
It's probability of free given spam times probability of spam plus probability of free given not spam times probability of not spam. But we don't have not spam.
Can you calculate
Oh,
it?
it's okay. Yeah, sorry. Just
No worries. Okay. So what is probability of the word free in the email given that it's a spam?
0.6%. It's 60%. 0.6.
Yeah. What is the probability that an email is a spam?
0.4.
The denominator also is the same on the first part. What is
Plus
probability that the word free is there if it's not a spam?
0.04 times 0.6.
And probability of not a spam, if I know probability of an email is a spam is 0.4, then probability of not a spam is the complement and is 0.6. And the answer is 0.79. Okay. So again, just write the questions in terms of probability rules first, probability notations, then write the simple formula for that, if there is any. Then find out what is given to you in the problem statement. If what you want is not given in the problem statement, then just go ahead and rewrite the numerator and denominator based on the things that have been given to you in the problem statement. Replace the numbers and find the value. Good? Okay. Any question? Good. Guys, the next thing I want you guys to do is to please go to module 1 and then go to in module 1 there is a folder at the bottom, extra practice problems, and in that one I uploaded a couple of questions. There is a file I uploaded and that has a couple of questions. Open that. Did you see the file, guys? Did you open it?
Yeah.
Yes.
Yes.
Yeah.
Okay.
Yeah.
Perfect. So these questions are here, and then at the end of the day, I'll also post the videos of today's class where we went through the problems in this folder as well. If you want to watch the video again or double check something, so that will be there. Okay. Okay. Now let's go through problem 1. A player of the video games is confronted with with a series of 3 opponents, and for each one of them he has 80% or she has 80% chance of defeating each opponent. Assume that the results from opponents are independent. What is the probability that a player defeats all 3 opponents? So this player is playing with 3 different opponents. These opponents the results are independent from each other, meaning that the results of the first opponent is not going to affect the second one or third one, and vice versa. Okay, so these games with each one of these opponents are independent from each other. The question was, what is the probability that the player defeats all 3 opponents in a game? Can you just write this question for me in terms of just probability notations? It's probability of
First.
Game 1, game 2, game 3.
I would say first
Opponent 1, opponent 2.
defeating first opponent.
First
And
given.
where do you see given?
Okay, not given.
And
Intersection.
2. Yeah,
No.
intersection.
There is no given here, right? It just says what is the probability that all of them are defeated. So the probability that the first one is defeated, and the second one is defeated, and the third one is defeated. Right? That probability is probability of all 3 he defeats all 3 opponents. Okay, so that's the probability of defeating all 3 opponents, meaning that defeating the first one and second one and third one. Given the fact that we know the results of any one of these opponents is independent from each other, I want to go back to this general rule. Probability of A and B and C, if I know that the results of A and B and C are independent from each other, how do you write this?
Probability of A times probability of B times probability of C.
Okay, so then given that, how can I write probability that I want? Probability that I defeat the first opponent, and I defeat the second opponent, and I defeat the third opponent. So I just multiply these probabilities. Probability of A, probability of B, probability of C. What is the probability that I defeat the first opponent, or the guys?
0.8.
That I defeat the second?
0.8, and then the third one would be 0.8 as well.
0.8. Okay, so that will be the answer for defeating all 3 opponents. And part B says, what is the probability that the player defeats exactly 2 opponents? Okay, so let's see how that's. So this is opponent 1, opponent 2, opponent 3. What are the scenarios in which I defeat exactly 2 opponents?
The scenarios would be 1 and 2,
1 and 3.
2 and 3. Two and 3.
And then
One.
1 and 3, right?
Yep.
Yep.
So the cross ones meaning that the player gets defeated, and the check mark means the player defeats the other opponent. Okay, so these are scenario 1, 2, 3. So the probability that the player defeats exactly two opponents, meaning that scenario 1 happens or 2 happens, scenario 2 happens, or scenario 3 happens. Okay? Or that means they are added to each other. Now, what is that probability that the first one happens? First scenario? Everyone agrees?
Yeah.
Yeah.
Or second one happens, second scenario happens.
So you would say this is the probability of at least the opponent, the player losing at least one game.
No, this is exactly one game because at least means you go to 2 or 3 as well.
Okay.
Okay, so the probability that this player defeats exactly 2 opponents, meaning that scenario 1 happens, or 2 happens, or 3 happens, and because of that, we have to add these probabilities of scenario 1 and 2 and 3, and that would give us the result. Okay, let me ask you this question. Probability that player defeats exactly 2 opponents given that he or she defeats the first opponent. Probably that this player defeats exactly 2 opponents, given that we know he has defeated or he defeats the first opponent. What are the scenarios under which this can happen?
Scenario 1 and 3.
Exactly. So the probability that he defeats exactly 2, given that he has defeated the first one. So this is the one scenario where he has defeated the first one and the total of defeat is exactly 2. And this is another scenario when he has defeated the first one and the total defeat is 2. So given the fact that he has defeated the first opponent is only this and this, now what is the probability that he defeats 2 is scenario 1 and 3. So I only need to add the probability of scenario 1 and 3, only these 2. Does that make sense?
Yes.
Good. Okay, let's go to the second problem, guys. Okay, computer keyboard failures are due to electrical connects 12% or mechanical defects 88%. Mechanical defects are related to loose key or improper assembly. Electrical connects are related to defective wires, improper connections, or poorly welded wires. Find the probability that the failure is due to loose key. First, remember what I said? First, write down the probability that the question wants from you based on those notations. What does this probability wants from you? The probability that the failure is due to loose key. How do you write it? right? The failure is due to Lusky. Nothing else, no and, or, given, condition, blah, blah. Just a simple, what is the probability that the failure is due to Lusky? Okay? Remember I told you in previous session, and I think I mentioned in today's session as well, when you want just probability of one thing, it's usually total probability rules, meaning that you have to condition that on a bunch of things. Obviously, problem statement has not given us probability of an error due to Lusky. Has it given, do you see anything just related to the Lusky that says probability of an error due to Lusky is this much? Is there any sentence that is similar? This is
No.
important, guys. Okay. So now we said, just since it needs just probability of one thing, let's say probability of A, is usually, these type of problems are usually total probability rules. How do you write probability of Lusky to be able to find it? Okay, before we answer that question, let's summarize what is given to us in the problem statement. The first sentence: computer failures are due to faulty electrical connects, 12%, or mechanical defects, 88%. How do you write the first sentence? Probability of Do you hear me, guys? Or I get disconnected?
I can hear you.
Okay. How do you write the first sentence? Probability of? What is hard, guys?
If it's due to loose keys, it's point.
No, the first sentence. First sentence of the problem statement. How do you write that probability? That's my question. I'm just trying to summarize what is given to us in the problem statement.
Oh, of electrical connections
If it's electrical,
and mechanical defects.
how much is it?
12%.
Probability that an error is mechanical is 0.88. I'm just trying to summarize what is given to us in the problem statement. Then the second sentence says mechanical defects are related to loose key 27% of the time, and or improper assembly 73% of the time. How do we write that part?
Would you put loose given mechanical?
Okay, because see, when you read that statement, is mechanical defects are related to loose key 27% of the time. The part in that sentence that is for sure given to you is that we know for sure it's mechanical defects, and 27% of the times they are related to loose keys. So it's for sure mechanical. So given that it's mechanical, what is the chance that is related to the loose key?
27%.
How about the second part?
It's improperly assembled, and it's 73%. And given mechanical.
Assembly. Given that it's mechanical is 73. Okay. How about this third sentence? What do you get from the third sentence? Electrical connect defects are caused by defective wires, 35%, improper connections, 13%, or poorly welded wires, 52%. How do you write that?
Defective wires, given that it's electrical, and then improper connections, given that it's electrical.
Okay, so in that sentence, it says electrical defects are due to this and this and this, which means that the part that we are sure about is that we are talking about electrical defects. and they are related to defective wires 35% of the time. They are related to improper connections, given that they are electrical 13% of the time, and they are related to welded wires, given that they are electrical. That's 52% of the time. Okay, so this is what is given to us in the problem statement. Now I want to find probably that I pick a computer keyboard and the error is due to loose key. Okay, do I have such a thing in the problem statement? The problem doesn't give me the probability of having an error just due to loose key. It tells me loose key condition on something, but it doesn't give me the probability of loose key error alone. Okay. So now how can I find the probability of loose key? If you see just one thing, that's always total probability of root. How do you write probability of loose keys? What is the formula? We want to be able to rewrite this based on whatever we have in the problem statement.
Probability of loose key given mechanical
Given that
times
error is mechanical, multiplied by probability of mechanical plus probability that the loose key, we see loose key error, given that the error is electrical, multiplied by probability that the error is electrical. That's just the general formula, right? What is the probability that we see loose key error given that the error is mechanical?
0.27.
What is the probability that the error is mechanical?
0.88.
Plus, what is the probability that we see loose key error if error is electrical? These three. It's one of these. Error is electrical for sure. What is the probability that is related to the loose key?
0.
What is the probability that the error is electrical?
0.12.
Okay, so it's just 0.27 multiplied by 0.88. Any question? Let's see what part B wants from us. What is the probability that the failure is due to improperly connected connection or poorly welded wires? The probability that the error is related to connection or, how do you write that? Or
Union.
Relate or improperly welded wire. Okay, that's what the question wants from us. First, let's just write this simply based on the formula. This is addition rule, right? How do you write this? This is probability of A union B. How do you write that? Is
Probability of connection plus probability of plus probability of B minus probability of A and B's intersection.
Exactly. Okay, so now how can I write the form? There's this probability that I want from problem statement. So it's probability of improper connection plus probability of the error is because of welded wire minus probability that the error is because of improper connection and welded wire. So I said and, but let me just write, instead of and, I'm just going to put the formula, which is intersection. Okay. What is the probability that the error is because of the connection? How do you calculate that? If I need, do I have probability that the error is because of connection anywhere in the problem statement, anywhere in the red? Just a simple probability that the error is because of the connection. Do I have it?
No.
So now I want to calculate probability that the error is because of connection. So how do you write it? It's just one thing, and I said if you just want to calculate probability of one thing, most of the time it's total probability rule. How do you write that? Probability that the error is because of connection. Guys, how do you write this? We want to write it based on whatever we have in the problem statement.
So probability of connections given mechanical times probability mechanical
That the error is mechanical multiplied by probability that the error is mechanical
plus probability of connections given that it's electrical times probability of electrical.
multiplied by probability that the error is because of connection given that the error is electrical multiplied by probability that the error is electrical. Okay. And then what is the chance that the error is because of connection if we know it's mechanical? The error is mechanical are these two. What is the chance that it's related to the connection?
0.
0. Multiplied by probability that the error is mechanical, 0.88, plus, what is the chance that the error is because of connections, given the fact that we know it's electrical?
0.13.
0.13, and 12% of the error are electrical. So the result is just 0.13 multiplied by 0.12. Okay? So if you look at the problem, you will see that here in this problem, we have condition on mechanical or electrical. So those are the two things. So when you want to write the total probability rule to find what is the chances that the error is related to the connection, you need to condition on only two things, mechanical or electrical, because these two types of error were enough to partition our sample space. So if this is all the defects, they are either electrical or mechanical. These two partition, and then electricals are divided into some parts and mechanicals are divided into some parts as well. But these two are the main connections of our system. Electrical are our main partition of our system, electrical and mechanical. So when you want to write the total probability rule, these are the two probabilities that you're going to condition. Okay. Part C. Any question, guys? Okay. Part C. What is the probability that the failure is electrical and related to poorly welded wire? How do you write that one? Just write it based on the notations. The probability that failure is electrical and related to poorly welded wires.
Wire to electric.
Electrical at intersection.
Can you repeat one more time louder, please?
Electrical intersection wire.
Electrical and
Wire.
poorly welded wire. And this. Okay, so this is important that you read the problem statement and you can write it based on the probability terms. Okay, so how do I, so this is probability that the error is electrical and related to poorly welded wires. Okay, how do I write this? Remember, I told you in previous session, there are two ways for you guys to write this. What are those two ways? How can you rewrite this probability? Guys? Philip, you can answer.
Probability of electrical given wire.
Given that probability that the error is electrical, given that is related to welded wires, multiplied by probability of welded wires. What is the other way?
Probability of welded wires given electrical.
The error is
Times-
because of welded wires, given that is electrical, multiplied
Times
by
probability of
that the error
electrical.
is electrical. Both these formulas are correct. Which one is the one that I'm going to pick to rewrite this probability?
No, the second one.
Why?
You're
Because you
given a probability.
already
of
have E.
I'm going to use the second one because for the second one, I have the probability here. Probability of welded wires, given that is electrical, I have, and probability of electrical, I have. If I pick the first method, I don't have those components in the probability. Okay? So I'm going to pick the second one. Now, then what is probability of welded wire given electrical? The probability that the error is because of welded wire given that we know it's electrical is 0.52. And then probability of electrical is 0.12. Probability of electrical is 0.12. So that's the answer. Okay? All good? Okay. I'm going to pass question 3, guys, for now. I'm going to jump to question 4. Okay, question 3 is very similar to the previous one, so I will get back to it later, but I'm going to go to question 4. Okay, data for 200 machine parts are summarized in the table. So they look at the age condition that is in the rows, coarse, moderate, or smooth. And then they look at also the depth of the bore, which is above target or below target. And those are the 2 columns for these 200 parts. Now let's see what are the questions. What is the probability that a part selected has a moderate age condition and a below target bore depth? So the probability that a part has moderate age and below target bore condition. Okay, let's go to the table. So these are coarse, moderate, and smooth, and above target and below target for the depth of bore, and 15, 24, 48, 10, 21, 82. Okay, so oops, so that's the table. So what is the chance that when we pick a part, it has moderate age. Which row is moderate age? Or row or column?
The one in the middle.
The row with moderate age. And below target board. Which column?
One to the right.
So what is the chance that a part has moderate age and below target board?
21.
So 20 parts, 21 parts have that condition. 21 parts out of
The total.
total of 200, because total is 200 parts.
200, I think.
Yeah. That's the problem. Okay. What is the probability that the selected part has a moderate age condition, moderate age or a below target board depth? So the probability that the part has moderate age or below target bore edge. How do you write this? So first of all, what is this probability? How do you write this? Total, the addition probability. How do you write it? We just talked about it, guys.
M union B.
Probability of
M.
moderate age
Oh.
Plus probability of
below target bore
minus
probability of moderate age
intersection
and below target bore. Okay. So now, what is probability of moderate age? That the part has moderate age. Which row or column?
The same one.
The part has moderate age. The second row. That's how many parts?
45.
Out of 200. What is the probability that the part has below target bore?
The column, so it's 82 plus 21 plus 10, which is
113.
over 200.
Minus probability that the part has moderate age and below target bore?
We just got that, right?
21 over 200.
100. Perfect. Okay. So that's that. Part C. What is the probability that the part selected does not have a moderate age or does not have a below target bore? So probability of no moderate age or
No below
no below
target.
target bore. Okay, how do you write this first? This is A union B. How do you write this? Addition rule. No moderate age
Plus P, no below T or BT.
below T, below target and more.
Then minus the intersection between them.
Exactly. No moderate age and no below target bore. So now, probability of no moderate age. How do we get that part? No moderate age. The chance that moderate the part does not have a moderate age. Where is it?
Isn't it supposed to be the prime of moderate age?
Okay, where is it? Which row or column?
It's the first column. So it's 15 and 48.
First column. So I just want no moderate age. I'm not caring about the bore part.
First and third row.
First and third row.
First and third row.
Right? So it's first and third row. No moderate age. How many parts is that?
155.
155. So we are adding basically 15, 10, 48, 84, 82. And you said 154?
155.
155 out of 200. Okay. What is probability of no below target bore?
It's the first column. So it's 15, 24, 48.
Exactly. No below target means above target. So if we add these three numbers, it's
87.
87, assuming that these numbers are correct, minus probability of no moderate age and no below target. No moderate age is in the first row and third row.
Would it be 15 plus 48?
Exactly. And no below target, meaning that above target. So the ones that are in the first column and first row or third row are just for 15 and 48. That's how many?
63.
And that's the answer. D, what is the probability that a part has a smooth edge condition given that it has above target bore depth? Probability of a smooth edge given it has above target bore. Above target bore is this column. What is the chance that the part has a smooth edge as well? What is the chance that the part has a smooth edge given that we know it has above target bore?
48 over 200?
48.
Exactly. I want you guys also recalculate this later using conditional probability formula to make sure you get the same number, because if you use the formula, we are always safe. And last, what is the probability that the part has below target bore given that it does not have moderate age? Below target bore given that it does not have moderate age. No moderate age. Below target bore if we know that the part does not have a moderate age. So if the part does not have a moderate age, where are we? No moderate age.
First and
third row.
First and third row. What is the chance that the part has below target bore if we know we do not have a moderate age?
92.
It's just 10 and
82.
That's 92 divided by 200. And again, for this one, recalculate it using conditional probability rules, and then make sure you get the same number. Okay, let me see. Okay. Guys, how many of you need to go? I'm okay to continue with solving the problems, but
Yeah, I have some stuff on.
Are you okay? Are you guys okay?
I would like to go over like a problem with the Venn diagrams because I'm kind of confused about those.
Okay. So for those of you who have a class and you need to go, please feel free to go. I will post the videos. Let me just make sure everything is good and we're safe recording. Yeah. Yeah. So I will post the videos related to today's session. In case you need to go, you can watch the video later. And for those of you who can stay, please, you are more than welcome to stay and we go over the next couple of problems. Okay, let me go through the next two problems and then we go over a Venn diagram. Is that okay?
Sure.
Okay. So let's go over problem 3. Problem 5. It's just one section, but it's a good problem. I put it because it's a little different from everything we did so far. Okay. So problem 5. For 300 randomly chosen road, we have given you the level of disaster that has happened and also the level of debris that have happened in those roads. So the level of disaster that can happen is low, moderate, or high. And then the level of debris that have happened on those 3 rows have been given to you in this problem. So let me do. So level of debris is low, moderate, high. So this is the level of disaster. And then the level of debris is low debris, moderate debris, and high debris. And this is 80, 50, 30. Okay, so what is the question? The question says, what is the probability that a randomly selected road is under heavy debris given that the earthquake, so this disaster is an earthquake. So it can be low level earthquake, moderate level earthquake, or high level earthquake. So what is the probability that the road is under heavy debris given the fact that the earthquake is either moderate or high? So this is important, guys. So how do you write this? So I want you guys to think like 10 seconds, 20 seconds, and tell me how do you write this based on just the probability notations. This is the question. Probability that the road is under heavy debris given the earthquake level is either moderate or high.
So do you do probability of heavy debris given that it's either moderate or high. So it has to have a union in it, right?
Yeah. Given that the earthquake is moderate or
high.
Earthquake is high. Okay. Probably that the high level of debris is in the road, given that the earthquake is moderate or high. So, so this is important. We never had anything like this condition on this. Okay. So now, let's just write this based on typical rules. So how do you write what is the numerator based on just conditional probability rule? How do you write conditional probability, guys?
It would be HD H.
This is A.
Yeah.
And this is
B.
How do you write probability of A condition B? Just tell me simple formula. A and B.
A intersection B divided by probability B.
And EM union EH So that's my B, probability of A and B divided by probability of B. Okay, now, how do you write? Okay, now, in the numerator, let's see what we have in the numerator. In the numerator, what I have is, so I'm just writing it generally, is probability of A intersection C union D. How do you write this? We had that in the, I believe, second video or third video. How do you write this?
A intersection C, and then union, union A intersection D.
Exactly. So this part is going to go to the first one, and then union. This part goes to the second one. Okay. So it's probability of A intersection C union A intersection D. Okay. Now, how do you write this? Total probability rule, guys. So let's assume this is the first one is, I'm just making up letters. Let's say this is
It's A given B times probability B.
No. Just give me the total probability rule. So let's assume the first part is X, the second part is Z.
Oh, I'm not sure.
But this is the total probability rule. So this is probability of X union Z. How do you write this one?
Probability of X plus the probability of Z.
Exactly. Probability of X, which is A intersection C, plus probability of Z, which is A intersection D. What else?
Minus the probability of
Their intersection, right? Minus probability of X intersection Z, which is?
Oh, I thought that was the addition rule.
Yeah. What did I say?
Never mind. Okay.
Minus probability of A.
I was thinking you used the multiplication rule because
No.
I just forgot it was a union.
No, don't worry. Minus probability of X intersection Z. X intersection Z. Okay? So that's that. Now, we have to find probability of A and C. Okay, no. This was just a general rule I told you guys here, right? So this was just a general rule. Okay? Now, we have similar thing here in the numerator. See, I said A intersection C union D. So it's pretty much something, intersection of union of these two. It's similar to this one, right? It's exactly the same rule. Right? So let me just write this one more time here. So I want to calculate probability of HD and EM union EH divided by probability of EM union EH. Okay, so that's what I want to calculate from problem seminar. I just wrote it at the bottom so that I can see what we want to do. Okay, now let's just rewrite the Numerator based on the general rule that we just talked about. It's probability of HD and EM or HD and EH, right? This is just what we wrote here. This is just like this, no difference. Multiply, divided by probability of EM union EH. And then numerator again is probability of HD intersection EM, the first part, plus probability of HD intersection EH, that's the second part, minus probability of their intersection. Since I did not have like the space to write it in one line, I write it in just in 2 lines. So this divided by probability of EM union EH. Okay, now let's calculate the numerator. What is probability of high debris and earthquake moderate? High debris. High debris and earthquake moderate. So high debris is here, earthquake moderate is here. So only 50 rows are in both, high debris and earthquake moderate, okay? So that's 50 out of 300. What is the probability of high debris and earthquake high? High debris and earthquake high. The third row is only 20 parts have both conditions. Minus the probability of high degree and earthquake moderate and high degree and earthquake high. High degree and earthquake moderate is here. High debris and earthquake moderate is here. High debris and earthquake high is here. Do they have any intersection? High debris and earthquake moderate is here. High debris and earthquake high is here. Do they have any intersection?
No.
No. Minus 0. Divided by earthquake moderate. Denominator is probability of earthquake moderate. That's another addition rule. Probability of sorry. Yeah, wait. We can easily calculate that. Probability that the earthquake moderate or earthquake. Probability that the earthquake is moderate or earthquake is high. Where are we? Earthquake has moderate level or high level? Which columns or row?
Column 2 and 3.
Column 2 and 3. Earthquake has moderate level or earthquake has low level? 2 and 3. And those are 70, 50, 120, 130, 140, I believe. And whatever is the answer. Actually 70 over 140. Okay, so the denominator is earthquake moderate or earthquake is high. So that's these two columns, earthquake moderate, this column, earthquake is high is this column. And they have no intersection too, so we don't need to worry about their intersection. So the only part in this question that maybe that was not similar to whatever we had done before is this part, probability that the road has high debris, given that the level of earthquake is moderate or high. So just write everything. So as long as you can write the problem statement in terms of the probability rules, the probability notations, then you are good to go. Then this whole thing is just another, it's like B. So this is the numerator of this conditional probability of A and B divided by probability of B, and then A and B, just in this example, is a typical situation like this. A and A intersection C union D, and this is the general rule, and we just rewrite the numerator based on this general rule, and then we get the probabilities from problem statement, and we are good to go. It's a little long, but it's not hard. Just practice, like every single element of every single thing I put in this page, like right now, you know to give it based on the videos. So just refresh your mind regarding the formulas, put those elements, write the formulas, and you are good to go.
I have a question. Can you just do a Venn diagram one? Because I have to actually leave in a few minutes. So I have somewhere to go.
Do you have any specific question in mind?
I was just like looking at the ones that were on the homework, and I was just a little bit confused. I know there's one on the new homework, but I think I'd be able to figure it out based on like the ones on the first homework that we did.
I'm going to the first one.
Yeah, I'm confused about those.
The ones where I asked you to tell me what is the shaded area, is that the ones?
Yeah.
Okay. So, for example,
or like if you were to do that, but with like probabilities instead. I think there was one that had the picture with the A, B, and C where they were overlapping and stuff. I was kind of confused about those.
Okay. I'm going to solve one. I don't know if it's exactly that's the one you want, but let's look at this.
Yeah, something similar, not like exactly.
A, B, C. Okay, and this is the shaded area. And I asked you, what does this show? What is the shaded area? Okay. So, can you tell me what is this area?
So I have to get red area.
Yeah, just the red area.
Okay.
It's not hard.
Yeah, I just don't know where to start.
Just tell me, like.
That one was something, I think it was like.
It's just the red area, right?
Yeah, but it's when they overlap.
Let's assume this is
Wouldn't it be the probability of A intersection B?
I need this part.
And
right?
C.
Exactly. So this pink part is A intersection B. Okay? And the same for here in this first graph as well, the red part is A intersection B, meaning that anything that is here is in A and is in B. Do you agree?
Yeah.
So those are A and B. Okay. Okay, tell me what is this part?
A intersection C.
Exactly. So that's A intersection C. Okay. Now, and obviously this part, how about this part?
B intersection C.
B intersection C. Okay. So now, let me go back and draw this one more time. Okay. Now, in this one, how can you, what are the things that you see in this?
So it's the total of C and then A intersection B.
Okay, A intersection B is there and the total of C is there too, right? So what should I put between A and B? So let's see. What should I put? Intersection or?
Union.
Union. Okay, so that's union. So that's that. So okay, so you're good with that. Now, what is the other way for me to read? So based on the formula that we just talked about, how else you can write this?
Oh, you can distribute it. So it's A union C and then intersection B intersection or unions.
Good. So in the question, I have asked you what this shaded area shows, and I have given you this and this. So the answer is both these answers. Okay, now I want to go back to the third problem of extra practice for Module 1. In this problem, we have 500 containers of orange juice, and out of these 500 containers, 5 of them are defective. And we select 3 at random without replacement, and we want to calculate what is the probability that the first 2 selected are defective. So I'm going to use A1 to show the first selected container is defective, and then the second one is defective. So I want to calculate probability that the first container is defective and the second container is defective. Okay, so the A1 and A2 are not independent from each other. So basically, because if I know the first one has the first container that I selected has been defective, it definitely affects the probability that the second container was defective. So I'm going to write it as just a simple definition of intersection. So this is probability of A2 condition on A1 multiplied by probability of A1. So what is the probability that the second container is defective if I know the first one has been defective? So overall, I have 5 defective containers. If the first selection has been defective, meaning that 4 of them are left, out of how many? Out of 499 containers. Overall, I had 500 containers, but I already picked one for the first container, so I have 499 left. Multiply by probability that the first container is defective. So I have 5 containers that are total defective, and out of 500 total containers. So since this is the first selection, I'm just going to consider all 500 containers and the total 5 defective items that I have. Okay, so that gives us the probability that the first container is defective and the second container that we pick is defective. The part B calculate once the probability that the second one selected is defective, given that the first container is not defective. Okay. What is the chance that the second container is defective, given the fact that I know first container that I selected is not defective? So total, I have 499 containers left because I already have selected one. That's the first one. And out of these 499, how many of them are defective? all 5 defectives are left. Why? Because the first container that I picked is not defective. So all 5 defective items are left. So that tells me the probability that the second container is defective, given the fact that we know first container is not defective.